Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another Locus problem. If you haven't seen my previous Locus video, please check the link on the top right corner. Today we will solve the following problem. Consider the following two ellipses E1 and E2. Ellipse E1 is x squared over 4 plus y squared equals 1, and ellipse E2 is x squared over 4 plus y squared equals ax plus by. Here, A and B change in a way that two ellipses are always congruent. Under this condition, find the equation of the locus of the center of ellipse E2. Alright, let's check what we have here. The first ellipse E1 is very easy. It is an ellipse centered at the origin, having semi-width 2 and semi-height 1. For the second ellipse E2, we need a bit of work. Simply put, it is a shifted ellipse. You see, if we shift the first ellipse so that its center moves to point P, Q, then the equation of this shifted ellipse is given as x minus p squared over 4 plus y minus q squared equals 1. That is, you replace x with x minus p and y with y minus q. So let us convert the equation of ellipse E2 into the similar form. In order to do that, we require a trick called completing the square. So this is the equation of the ellipse E2. So we have x squared over 4 minus ax plus y squared minus by equals 0. And let's write it as x squared minus 4ax over 4 plus y squared minus by equals 0. Now, in order to complete the square, we add 2a squared here. And here we have to add b over 2 squared in order to complete the square. And we have to add these on the right hand side as well. So on the right hand side we have 1/4 of 2a squared plus b over 2 squared. Therefore we have x minus 2a squared over 4 plus y minus b over 2 squared equals a squared plus b squared over 4. So now we can find the center of ellipse E2, which is 2a, b over 2. We have to find the locus of this point, so we let this point as capital letter X, capital letter Y. So we have to find the relation between X and Y. In order to do so, we use the given condition in the problem. A and B can change in a way that two ellipses E1 and E2 are congruent. This condition can be handled quite easily. If two ellipses E1 and E2 are congruent, then the right-hand side of the above equation of ellipse E2 must be 1. So we have this constraint for A and B. In other words, A and B can only have values that satisfy this relation. Alright, now we have obtained alternate expression of our problem that is kinda more straightforward. The problem is equivalent to if a squared plus b squared over 4 equals 1, what is the locus of a point 2a, b over 2? So let's find this locus. From here, we have a equals x over 2 and b equals 2y. If we substitute this into our constraint, a squared plus b squared over 4 equals 1, we have x over 2 squared plus 2y squared over 4 equals 1. If we simplify, we have x squared over 4 plus y squared equals 1. Here, capital letter X and Y are notations that we have introduced, so let us change those into more generally used small x and small y. Then the equation of the locus is x squared over 4 plus y squared equals 1. But wait, isn't this just the equation of ellipse E1? Well, yes it is. This means that if A and B change in a way that two ellipses are always congruent, then the center of the second ellipse is always located on the first ellipse. And that is our interesting answer. Finally, let us visualize our result using Desmos graphing calculator. This actually requires a bit of explanation. First, we have this red curve. This is ellipse E1. Next, we have to introduce parameters a and b. Here they are related by this relation, a squared plus b squared over 4 equals 1, which comes from the congruence condition. From here, we can solve for b and obtain b equals plus minus square root of 4 times 1 minus a squared. So we have two possible values for b, and let us call them b1 and b2. b1 is with the plus sign, and b2 is with the minus sign. Next, let us construct the ellipse E2. It is given as x squared over 4 plus y squared equals ax plus by. But since we have two expressions for b here, let us define two ellipses with ax plus b1y and ax plus b2y respectively. Then we obtain two ellipses which are both E2. The top one is the one with b1, and the bottom one is the one with b2. And as you can see, if we change the value of a, then values of b1 and b2 will also change accordingly. And the green ellipses representing ellipse E2 also change. Finally, let us create the center of the ellipse E2. The center is 2a, b over 2, so using b1 and b2, let us mark two centers, 2a, b1 over 2 and 2a, b2 over 2. They are these blue dots. And you can clearly see that if we move the second ellipses again under the constraint I have explained, these blue dots are always located on the red ellipse. That is, the locus of the center of ellipse E2 is ellipse E1. And that was all for today's video. Thank you all for watching, and I will see you in another video.